Hello and welcome to my channel, Follow the Rainbow. Today we'll be learning all about electricity. What is it? How does it work? Where do you find it in the home? How do we use it? Electricity is made up of very small particles that you cannot see. They're called electrons. They're so small you can't see it, and if you used a magnifying glass, it makes things bigger, right? So you can see things. It might help, but even with the most powerful magnifying glass that I have, and if I use two magnifying glasses, it makes things even bigger, right? You still can't see what very small particles are on about the electrons. So if you used a very powerful magnifying glass, what you call a microscope, and if you had one that was so powerful, you might be able to see something called atoms. And the electrons are the things that is what makes up the electricity. The microscope, a super microscope, we can see things very small, very small. You'll be able to see something called atoms. Imagine that apple is an atom, that we had this really expensive microscope and we could see an atom. Around, stuck on top of it, could be something like that. Now that red tomato there is representing an electron. Now if you look the way it is, it's actually quite, it's stuck, it's on top of the apple and it's not rolling off, it's not falling off, it's not moving around. And in things that do not, what you call, conduct electricity, the electron cannot move from the atom. No matter what you do to it, you can give it a little prod here and there, it's not going to move. But in things that do conduct electricity, things such as metals, the atoms are not binding the electrons so strongly. So on something like a spanner, which is made of metal, imagine I had my super magnifying glass or super microscope and I looked really closely. I'll be able to see, imagine these oranges are the atoms of the spanner. I should be able to see also electrons, but the electrons for the metal spanner are not tightly bound to the atom, they're loose, they can kind of move around like this. And any little thing, imagine it was like that, it'll be fine. Imagine this was my toy car, on a level ground it would be fine, nothing's moving. But as soon as I tip it, as soon as I give it any kind of incentive, the car will roll down the slope, and so will the electrons. And that pretty much is what electricity is. It's the flow of these electrons that are loosely bound to the atoms on certain materials such as metal and certain type of liquid such as water with salt in it. If you compare electricity to water, there is what you call an analogous comparison that you can make. So the flow of electricity is very similar to the flow of water. If you imagine I had this tin and I emptied out what was in it and I put water in it, and I drilled, for example, holes here, here and here, and I stood it up like so, okay, and I poured water on the top. Obviously the water will come out of these holes here, but the way they come out is very similar to the way electricity is passed through objects such as my earlier spanner. Now how do you think the flow of water, if this is my drawing of my can looking at it from the side, how do you think the water would flow looking at this? And if this was sitting on the edge of a table like so, how would it flow? Okay, the way it will flow, if the holes are the equal size, like the way I've done it here, equal size, what will happen is there's more pressure from the column of water on top of it, so the bottom hole will actually, the water will flow out further, and the one in the middle will flow, will kind of drop not so far away, and the one at the top with the least amount of pressure will kind of drop straight down like that. And that would be the way the water will flow out the tin can. Now the height of it, the height of this tin can, the higher the tin can, the higher the water pressure. So we can relate water pressure to voltage. Okay, and let's see how you spell that. So the height of the tin can is similar to, the higher the tin can, the more pressure is pressing on the water, the higher the voltage. Now what is current, or the flow of water? The current is the flow of water coming out of the tin can, or the current of water. But in electricity, the more electrons are passing through these holes, the higher the current. So there we go, there's an analogy with the pressure of the water pressing down, giving you the higher voltage. And which one has the highest current? It will be the bottom one. It'll be coming out the quickest, and it'll be more water. If you was to catch it, it'll be more water coming out, whereas the top one would be kind of dribbling down. Now there's one more thing that makes a difference. Can you guess what it is? If I wanted to change the amount of current flowing out of these holes here. Okay, if for example now I turn the can around and there's a big hole at the top and a little hole at the bottom, what do you think would happen then? So with my bigger hole at the top, smaller hole at the bottom, what do you think will happen? Do you think the water now will flow out much further, or would it be similar to the way it was before? I guess actually it will be similar to the way it was before, but now you've got a much bigger stream of water coming out. It will look a bit like that. But this one, what do you think happened that one? Because that one's about the same as that one, and that should be the same. Same kind of distance. So comparing then the current flow, which one has the most current? This time it could well be the top one, because you can see there's a bigger column of water, so the current flow would be higher this time at the top because it's such a big hole, and at the bottom the current will be the same as before because it's exactly the same, nothing else has changed. Now there's one big difference comparing the big hole and the little hole, and that is, yeah, one hole's bigger, it's going to allow more water through, more current through. And there's another word I want to introduce, which is resistance, which literally means stopping the flow of current, whether it's water or flowing in our case, the flow of electricity or the flow of electrons. Now the bigger hole allows more electrons to pass through easier, just like the bigger hole in the tin allows more water to pass through at a certain amount of time. Okay, so we've looked at what is electricity and comparing electricity to water, what you call analogy. They're very, very similar the way you think about them, the flow of electricity and the flow of water. Very simple really, so don't be worried or anything about learning electricity. It's very, very simple, very, very fun to do. And if you've liked and have learnt, particularly if you've learnt something from watching this, please press that like button, share your video with all your friends, and if you're already a subscriber, I thank you for watching this, and I shall catch you next time where I should investigate a little bit more about electricity.